All right. Uh, yeah, I think someone actually figured out what, yeah, I think someone actually figured out what's going on there, which is that I posted the link that was creating a new live stream on YouTube, which was stopping the one before. So I think I started a new live stream on YouTube now, which actually is going to work. So, okay, that's good. So we were talking about uh, the ll.c and the ArrayList.c. And the point I was trying to make is that, okay, so we can just use those. So if I go to main.ll.c, here is a use for the linked list. So we've already seen this kind of thing, right? So what I'm doing here is I'm creating an address list, which initially is just nothing. I then call create list. This is going to call, in this case, create list in ll.c. So this one, and that gets the address of the list. It'll malloc the list. It'll make head be null initially. There is more stuff on Discord. Array lists. C does not work. Okay. Doesn't it? Oh, okay. You need to refresh. So what you want to do, so because I fixed the link, so you can just fix this to .c and that would work. Or if you refresh this page, it will take you to, didn't refresh, but if you do refresh, still no. Okay, sorry, you have to manually, I apologize for this. You need to manually change this to .c. Okay. So, okay, all right. So we are back to business. So, okay. So here what I was saying is you have your create list and takes an address of LL star, mallocs it, sets the head to null, so the usual. And here we just have, like a bunch of basically create list, then we append 1, 2, 3, 4, 5, print it, then I delete the element at 0. Okay. So I now want to run it. That used to work before. Okay, this is array list. So I want to change it first to LL. And it prints like that. So it prints essentially whatever. So we appended 1, then we appended 2, then we appended 3, then we appended 4, but then we appended 5. So, and it prints in this order. If I wanted to, if I wanted to delete, in this case, the element at index 0, then it does it this. So here, it just prints a disorder. You can interpret 0 as either the first or the last element. Okay, so, all right. So here I have a delete at delete at 0, which basically removes the element from the head. All right. So the point I want to make is that you can now change the file that you're using. So here I can go to my configure tasks. And then instead of saying that I'm compiling before I was compiling ll.c and main.ll.c. So here I can say I still want main.ll, but I now want to use ArrayList.c, like so. So here, instead of including al.h, I'll include ArrayList.h. So ArrayList is the usual array list that we had before as well. And here, if I change ll to al, I can now, again, just run it. All right. So that's going to be like this. And here it's, so we appended 1, 2, 3, 4, 5, and it prints it in this order. If we remove the element at 0, it's going to print 2, 3, 4, 5. Make sense? So the idea is if I name them, and you've done it in the lab as well, if you got to that point in lab 4, the point is I can just create those different underlying data structures, and then I can swap out the linked list for an array list. And in principle, it could work the same, or it could work, in this case, slightly different because of the order in which it prints things. All right. So, and all it took is I just said, well, instead of compiling main.ll with ll, I'll compile main.ll with array list. I could, if depending on what I wanted, either name this kind of thing ll versus naming this kind of thing al, so that I'll know what the implementation was. Or I could just decide that I would rename this to ll, in which case I could just swap two completely different implementations, and it could still work with different kinds of properties. So I want to talk briefly, we already mentioned that, about the properties of the different implementation, right? So if you have something like a linked list, that would be like this. If you have something like an array list, I'll represent it as something like this. And you're going to have different kinds of complexity depending on what you do. So if you want to think about append, or like insert in my case, right? There's different things that are going on, right? So if you want to append to the array list, you can access index 5 immediately with arithmetic, but you need to reallocate the whole array and then move it. So in the worst case, the complexity is O of n, where n is the number of elements. On the other hand, if you want to do it to the linked list, can append to the beginning, in which case this is O of 1. Because you just make the head point to the new node, make the new node Make sense? So here there is kind of design choices. The way you sometimes have design choices in Praxis, they don't often show up directly when you're programming because a lot of the time it's not so much about design choices, it's more about figuring out like the one thing that works. But here you actually have a choice, right? So you can say, I want a list and I want to be able to append. Well, if you want to be able to append and you're using array lists, then append is going to take potentially O of n. In the worst case, like usually it's going to be O of 1 because usually you don't need to move the whole array list to a new location. But in the worst case, it would be O of 1. If you want to be able to append an O of 1 with the linked list, you actually can. So even with like the simple linked list that we have implemented here, you can just say, okay, so this is the insert, and all we do is we just create a new node and we prepend it. So exactly what's done on the midterm. Okay, makes sense? Questions about this? All right, no complaints about the Discord. Okay, everything's going good. All right, so this is kind of a little bit abstract, right? Because, well, like why do you need to append? What's going on? So what I want to do is an application of that, and then I want to use existing code in order to implement it. You will then implement the same kind of thing in the lab from more from scratch. So what I want to do is implement the queue abstract data type. So what's a queue? It's referred to as so people say first in, first out. And people say no random access. So random access would refer to so it's not really a list in the sense that you cannot just say, I want, index 1, index 2, whatever. All you can do is operations that are first in, first out. So the operations are named onQ and DQ. So this is add an element to the end of the queue. And you have DQ. So this is remove the first element from the queue. So the way it would work is kind of like this. So you can say like on Q5, and then you can say on Q6, and then you can say on Q1. And at this point, the queue is going to be, and you can write it either way, either 156 or 561. But the point is that when you do DQ, the output would be 5. So the way to think about it is Q in Canadian English is like a line, right? So it's like so here 5 is first in the line, and then 6 gets in the line, and then 1 gets in the line. So when you say DQ, what you want is the element that you put in first. So that's what first in, first out refers to. So 5 got in first. So if you do DQ, you get 5. If you do DQ again, you'll get 6. And the queue at this point is just 1. And at this point, you can also choose to unqueue at any point. So like maybe I'll unqueue 2, So at this point, the queue would be, so 1 is waiting in line, and then after that is 2. So if you dequeue twice, you'll get 1, and then you'll get 2. Make sense? So let's say that that is the kind of thing that I want to implement. Right? So I want to be able to say unqueue, and I want to be able to say dequeue, and that's those elements. So one thing I can do that's somewhat inefficient is to say, well, I'll just use a list, right? So I can say, I want something like the array list. And then when I'm dequeuing, I'll just remove this element and return it. And when I want to unqueue, I'll just append. So let me just do that. So first of all, is there questions? So I'll check Discord. All right. All right. So let's do that. So I'll create the H file. I'll name it QH. And that's going to be like that. And here, so I'll just define the queue structure. Name it queue. So here, what am I going to put here? So I don't want to re-implement the array list. What I want to say is I'll just wrap the array list around. So I'll include array list H. And here I'll just have an AL list. And the idea would be that if I want to re-implement it, one way I could do it is I would just implement, I'll just change the code here. So that's one possibility. So that I'll just name queue. And now I have my operations. So I have my create queue. So if people are typing with me, which online maybe they're not anyway, I will be trying to type things in as they go. So we'll malloc that. And then we also will need to create the list. So I'll create the list. That's over here. So I got my star queue. I have to call it PQ so that we're not confused about whether it's a pointer or not. So I'm getting this list. In order to create it, I need to send its address. So I'm getting the list, and then I'm getting its address. So now it created. All right. the reason malloc is underlined is it did not include s to the leg. Now that should be fine. So we also want an unqueue. Boom. All right, so create queue should be actually in queue.c, of course. So we'll copy and paste that. So you want a destroy queue. And we want an unqueue. And we want a DQ. So that's like that. And then in queue.c, we'll create those. Here we'll include the H. And now we want to implement those. So I'm commenting those out. And now I want to make a create queue, which we've already done. So that I'll just do very quickly. So this we have done. This is incorrect. And now, so once we've allocated that, we want to create the list. So address of, and this is EQ list. So that's all that we need to do in create queue to do a destroy queue. We'll free the list and then we'll free the queue. So this would be queue list. And we'll then free. So I'll now do an onQueue thing. So that's, again, going to take a queue, and it'll take the data. So now in array list, we had an insert, right? And then the insert was really an append. So I can just say insert list to the end. So that does exactly what we described over here, where we think about the queue as this list, and we just append to the end. That's basically what it means to unqueue. If you think that the queue starts here and ends here, append just means, so starts here rather and ends here. Well, depending on what you mean by starts and ends. So append means put on the right, and then DQ must mean get from the left. Okay, so we're going to go into queue.c. And now DQ is going to be basically get element at index 0, remove it, and return it. So that would be PQ. That would be like this. So what do we want? So we want to return. So here we just get, Q list array 0, right? And that's because the way the array list works is you just have an array where you store the data. So you go array 0, that's the first element. And now we also need to delete this. And we do have a delete thing, which was called delete list index, where we just go and delete it. And now we can just return it. Make sense? So now we have an onQ operator and a DQ operator. The way we did it is we basically just wrapped the list inside of this Q structure. So let's do a main Q. So that's going to be called main Q. Including image. And I'll do a Q. Create it. Sorry, this is Q.h. So I'll create the Q like so. So this is the address of Q. And then I want to be able to unqueue. So let's say 5. And I'll unqueue 1, Q2. And I want to be able to say, get me basically the 5. So that would be DQ. So print that. This. And here I'll call DQ. Yep. Do it again. And then I'll destroy the Q. So let's do that. I didn't. So we need to compile 3 files now. So we need to compile main Q together with Q.c together with ArrayList.c because we're using ArrayList inside of Q.c. So I'll go here and instead of the file, that is going to be main Q.c. And that is going to be Q.c. And we also need ArrayList.c because we need all code that's actually running to have been compiled. So that's going to be like this. And hopefully it runs the first time. We'll see. No such luck. But there's only one problem. It seems like not a huge problem. So we'll include stdio.h. Like this. And we'll run it again. Okay. Zoom is, wait, where's my run button? So we have undefined reference to destroy queue. Do we not have a destroy queue? Well, we do have a destroy queue. We possibly did not have a destroy queue here. We do have a destroy queue here. We have a destroy queue here. Maybe it's misspelled. I'll just comment it out. And there we are. So we printed out 5, which was unqueued first, and we printed out 1, which was unqueued second. So we correctly dequeued the 5 first, and then we dequeued the 1. All right, questions about this? So feel free to Zoom or Discord, anything. All right. So let's think about whether it is effective. So what we have essentially is a list. And what's going on here is when we insert, we basically append. So that's in the worst case, unqueue is O of n, but usually less than that, right? But in the worst case, it's still n, and that's because you might need to move. And then every time dq is O of n because need to move basically, I'll do it in Python notation. So something like this, 1 spot to the left. So quite an effect, right? But nevertheless, that is an implementation. So one thing that we'll do next time is implement this instead of using an array list, implement using linked list. So if you're using a linked list, so it will be like head, and then you could have, 5, and then you have 6, and then you can have 10, and then you could have 2, and then you can have null. So this is just a preview, but the idea is you can insert in O1, so you can insert over here. Like we discussed before. And if you keep track of where the last node is, can also append an O1. Right? So if you keep track not just of the head pointer, but you also keep track of where its guy is, all you need to do is to just add a new node in between the 2 and the null, and that would also be O of 1. So you can implement unqueue and dequeue so that they would be in O of 1. And this is answering a question from about like a week and a half ago from someone of, well, why did we even say that insert and linked lists could be in principle of 1 if you know where you are? Well, because in this situation, you do know where you are. You know that you only ever need to insert next to the head or next to what we'll call the tail over here. And then you just keep track of where the head's, which we've been doing all along. And then also you keep track of where the tail is, and you're done. So it is 11:59. I know that some of you need to go, but some of you have the lab, which does need the next 10, 15 minutes. So I am going to continue and going to talk about Python as planned. If you have to go, you have to go. It's all being recorded, so just watch it before tomorrow. Okay, so we're switching to Python. So this is not going to be kind of super difficult. This is not going to be kind of a super difficult topic or anything, because essentially what we're going to do is structs except Python. That's kind of everything that you need. That's everything that you need to know. So structs except in Python are called classes, and I'm going to show you how they work now. So So there are also methods and operators, and we'll get to one of those things very briefly today. But essentially, it's the same. So in Python, you can have something like stint, and then the way it works is you have to basically, you don't have to define any of the fields right away, but customarily it is done, and it is done like this. And I will autocomplete, and I will explain what's going on here in a second. So let's say that we have name and grade. That is this. So over here, this is two underscores. So this is underscore, 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 underscore init. Underscore is a special function. You've already seen many examples where the underscore indicates that something special is going on. And this is basically the equivalent of struct student, and then like car name and int age. And equivalent, I would say, equivalent, but in quotes, it's not quite the same thing. The way you would use it is I'll have my main thing. So the way you would use it is you would say student s, and here I can say whatever Bob 52, and I'll say s is student like this. There's a question on Discord. A field, or so self is not a field. So name and grade are the fields, and I'll explain what this is in a second. So one way to think about it is you are essentially saying s name is equal to Bob, and s age is equal to 52. So this is what it's doing. So inside, and you don't need to know this, like you could just say, okay, like this is how you do it. What's happening inside is when you say student and then this kind of round bracket notation, init gets called, And the self inside here is the student object that's being created. So the reason I'm saying this is the same as s.name equals Bob is that's what happens. So Bob gets sent to name and 52 gets sent to grade. And then this here, which is mandatory, this self is basically the thing that's going to be returned and assigned to S. But you can also just think about it in terms of I'm creating this. I'm creating this object, and you can think about it just as you're creating object in C with those initial values, where the manual initialization is going to be like this. So you can, but shouldn't. So you can, in principle, add anything. So you can also say like s dot whatever is equal to 5. And that is also going to be, it's called an attribute in Python, but you can think about it as a field that's named that you're just adding to this specific s. That is possible to do. Okay. So ordinarily, though, we would just say, okay, like I want to access the name, so I'll print s name, and I want to access the age, so I'll print s.age. And this is print, like so. And that would be this. So of course, yeah, so switching from Python to C is a little bit difficult. So I got the comment wrong and stuff like that. So here, oh, and then great. Okay, so it's not that Bob is 52, it's that Bob got 52 in the first. So okay. That now prints as a name, as a grade. So in Python, unlike in C, it's not that there are no pointers, it's that everything is a pointer. So the only way, so there's not a question of like arrow or dot. You always access the fields using dots. Okay, there is comments in the chat. So the init function initialize the object. Yes, that's exactly what's going on. Okay. So essentially, that's it. So that is how you can define a struct in Python. So let's define a so Q would need a way that we have in an array list. In C. So here, name it array, and initially it's empty. So you'll notice that here I just said self. So the self is mandatory, but there's no parameter because I'm not initializing it. So I'm just saying prove this field array and make it initially empty. So one thing that's better about Python than C is you have basically functions that when we were doing functions here, we had to just manually type like list in order for you to know that the list function is associated with the list objects, right? So we called it like create list, insert list, print list, and stuff like that. So in Python, what you can do, where's my Python thing? Right. Just one sec. All right, it's a little, so So what you can do in Python is something like this. So I'll just name it onQ. And this would be an item like this. So that's the same way. And here I'll do a DQ. And here I'll again do exactly, so there you can do it like this. But not do it. I want to do it the same way that I did it in C. So I'll say return is this. Then I'll delete array at 0. And then I'll return ret. And this is self array at 0, of course. Okay, so basically the way it works is you can call it in the same way that you called it in C. So I can say something like, oh, I did it in this unit instead of in the queue. You can say something like, okay, so I want to create the queue. So I'll say queue is equal to queue. So here, because init doesn't have any parameters, I just have the empty parentheses. The empty parentheses are mandatory. I can then say on queue, and then I can say queue item 5. I do have to say queue dot, and that's because the onQueue is inside the queue. But this is the equivalent of what we had done in C, right? So you just say queue.onQueue, so that gets you this function. And then you can say, okay, I want to onQueue 5. But you can also do a shorthand, and the shorthand would be queue dot onQueue 5. And this is the same as so essentially what Python allows you to do is write the function inside of the class. And because you write it inside the class, what happens is when you say something like queue.onQueue, what happens is what's called is queue.onQueue, where this queue goes to the self. And this is why inside of this onQueue, what I get to do is I get to say, well, you know the array that's associated with this particular queue, well, just get it. So just say self.array. That's the same mechanism as in C, right? Because in C, we would just send the pointer to the queue explicitly. So C would be like this. In Python, we can do something like this. Make sense? So otherwise, exactly the same. I want to tell you about just one more thing. So back to student. You can, if you want, define some stuff to do with students that's not just functions. So one thing I can do is I can define this function that's called LT. And it'll take self and it'll take the other. And what it'll do in this case is it will return whether self.grade is smaller than other.grade. So I can imagine using it like this. So I can imagine saying, okay, so I have like Bob is student, and okay, his name is Bob, so Bob 52, and then Charlie is Charlie, and Charlie got, let's say, a 50, not feeling generous today. And then what I might imagine doing is saying student LT Bob Charlie. And this would be false. And it would be false because actually Bob got more than Charlie. And the way it works is we just call student LT and we send Bob here and we send Charlie over here. And then we compare Bob.grade, which is 52, to Charlie.grade, which is 53. So that is what LT means. But another way to call LT is to just say Bob is smaller than Charlie. So what this does is it calls LT with self being Bob and other being Charlie. Okay, here's a question in Discord. So the question was, why do I use underscores? So the reason I use underscores, it's not just stylistic, right? So it's so that I can do something like this. So LT stands for less than. And the point is, if I use the then operator, that's a special thing, it's bound to LT. So that rather than just calling, LT Bob Charlie, I can actually use Bob as smaller than Charlie. Make sense? So, okay. So let's try this. So I defined Bob and I defined Charlie. And now I want to ask, is Bob smaller than Charlie? In the sense of grades, I'll comment this out. So that's like this. And as you see, no, that's not the case. Now, I have defined smaller than. I have not defined greater than, which I could, but I didn't. This would be underscore underscore GT. So here it's going to do just something weird. So that now works. I can also, of course, just decide that I mean something else by LT. So I can say maybe what I mean is I want to compare their name alphabetically. So just return self.name smaller than other.name. So that would be like this. And in that way, Bob is smaller than Charlie because Bob comes before Charlie in the alphabet. So that allows me to basically sort, or this is one way of sorting in a custom kind of way. And that's what you're doing in the lab. And that's why I'm keeping you for the extra time. So if I have David here and David got 100. So because I can now compare Bob, Charlie, and David, I can also sort them. So I can say, okay, so I have a list and I want it sorted, and I can create a list from the students. So I can just say, David, Bob, Charlie, and I want to print that. So it's not going to print very nicely, but if I make a special function that prints, like this, for example. So here I'm saying this is you convert to string, and the way you convert to string is like name and grade. And I run it again. Sorry, wrapper. Then here, what you get is, okay, we compared by comparing the names. And if you compare by comparing the names and you sort, then Bob would be the smallest and then David the largest, because that's how it is alphabetically. If we instead compare by grade, like so, then they're now sorted by grade when I sort. So the thing I had to do in order to display them nicely is I had to create a special function which returns a string that represents the object somehow. So here it returns, for example, Charlie. All right, that is everything that you need for the lab. So go and do the lab. Thank you very much. I will be back on Wednesday in person. I'll stay here for questions if you want any. There are questions. You can also unmute yourself and ask questions if you want. All right, I will see you.
Professor, can I ask a quick question? Sorry.